From the introduction of the F-117 Nighthawk attack aircraft to the B-2 Spirit, and the debut of the F-35 Lightning II fighter over the past 30 years, stealth aircraft have become a familiar sight to us all. Yet, looking at the low-altitude battlefield, helicopters equipped with stealth capabilities are few and far between. However, back in the 1980s, Boeing and Sikorsky provided a stunning, yet short-lived answer. Welcome to Cold War Miracle. In this episode, we bring you the Comanche. The Comanche attack helicopter. RH-66. In the 1980s, the U.S. Army was facing a variety of severe challenges. Most of its reconnaissance and attack helicopters were obsolete models from the Vietnam War era, whose performance had long fallen behind. At the same time, as the Cold War arms race continued to heat up, America's need for a new generation of modern helicopters became increasingly urgent. The Army needed more than just replacements for the Iroquois, Kiowa, and Cobra. It required a new aircraft that completely surpassed them in stealth, speed, and lethality. To this end, the Army launched the Light Helicopter Experimental Program. The goal was to build a multi-role platform that combined reconnaissance, attack, and utility missions all into one. Initially, the plan aimed to develop a multi-purpose helicopter to replace almost all of the Army's light helicopters. But as the requirements evolved, the project's objective shifted to a stealth helicopter capable of performing both reconnaissance and light attack missions. By the mid-1980s, the core objective of the program was confirmed. The new helicopter had to be able to penetrate deep behind enemy lines to gather intelligence, possess stealth and attack capabilities, and be able to counter advanced Soviet air defense systems. In 1988, the Army officially issued a request for proposals. Two major teams, Bell McDonnell Douglas and Boeing Sikorsky, participated in the bidding. After a long and rigorous bidding and evaluation process, the Army finally announced in 1991 that the Boeing Sikorsky team had won, securing a $2.8 billion contract. The new helicopter would integrate a massive amount of untested, cutting-edge designs and draw upon the stealth technology experience of the F-117 Nighthawk attack aircraft. It introduced the concept of the digital battlefield, utilizing networked sensors to transmit real-time data on enemy positions and troop strength to coordinate combat operations. Thus, the R&D team had to break through numerous technological barriers. The fuselage of the new helicopter was made of composite materials, consisting of only 350 parts, whereas a traditional helicopter of the same size has over 6,000 components. It adopted the faceted, angular design pioneered by the F-117 Nighthawk attack aircraft, intended to deflect radar waves. The fuselage was coated with radar and infrared-absorbing materials. Its designed frontal radar cross-section was 360 times lower than that of the Apache, making it even smaller than a single Hellfire missile. The new helicopter was not just a stealth reconnaissance platform, but also a formidable weapon for aerial combat and ground attack. Its weapons were seamlessly integrated into the stealth design. The internal weapons bay could carry up to 6 AGM-114 Hellfire missiles for striking armored targets and bunkers, or 12 Stinger air-to-air missiles for aerial self-defense. The new helicopter was also equipped with retractable stub wings. When enhanced firepower was needed, it could carry an additional 8 Hellfire missiles, or 16 Stinger missiles. In addition, a 20mm 3-barrel rotary cannon was mounted beneath the fuselage, holding 500 rounds with a firing rate of up to 750 rounds per minute, capable of effectively engaging infantry and light armor targets. To further reduce its radar cross-section, components like the cannon and landing gear could be completely retracted into the fuselage, enhancing both aerodynamic efficiency and speed. The entire airframe utilized Kevlar and graphite composite armor, capable of withstanding heavy machine gun fire and 23mm cannon strikes, drastically boosting its defense. The new helicopter was powered by twin T800 turboshaft engines, each delivering a massive 1,560 horsepower, with a ferry range close to 2,200 kilometers. Even without strategic airlift, it could self-deploy to overseas theaters for long-range missions. This robust propulsion combined with a streamlined fuselage gave the new helicopter incredible speed, reaching a maximum velocity of 320 kilometers per hour, making it the fastest helicopter in the world at the time. Its cruise speed reached 270 kilometers per hour, balancing both rapid transit and fuel efficiency. With a combat radius of about 250 kilometers, which was fully sufficient for all contemporary recon and attack needs. When flying at low altitudes, helicopters are most easily betrayed by the immense noise of their rotors, caused by aerodynamic interference between the main rotor and the tail rotor. To solve this, the new helicopter adopted a fantail design, using an enclosed shroud to dampen airflow interference and reduce noise. The canted configuration of the tail rotor further minimized its radar cross-section. Coupled with an advanced flight control system, it allowed the helicopter to fly forward, while facing backward, locking onto targets and opening fire without having to turn around. At the same time, the fan and fin design protected the tail rotor from striking obstacles like trees during low-altitude flights. Its composite tail rotor blades could even withstand hits from 12.7 mm caliber ammunition. The 5-blade main rotor featured composite materials and an anhedral tip design coated in tin boron, generating only half the acoustic signature of a conventional helicopter, making it much easier to blend into environmental background noise, while it could still be detected as it drew near. The drastically reduced noise signature severely compressed the enemy's reaction time. Furthermore, flush-mounted sensors and antennas left no protruding parts to reflect radar signals, rendering it highly elusive to enemy personnel and detection equipment. In terms of infrared stealth, it featured an innovative heat dissipation design that routed hot engine exhaust into the tail boom, where it was cooled by the shrouded fantail, before being expelled, all while utilizing an infrared suppressant coating to slash its thermal signature. Its IR signature was just a quarter of a standard helicopter's, making it incredibly difficult for heat-seeking missiles to lock on, providing a stark edge in low-altitude combat. The aircraft was packed with a sophisticated avionics suite for navigation, communication, and detection, including a digital fly-by-wire system, robust electronic countermeasures, and an advanced fire control system. The rotor mast could be fitted with the same longbow millimeter-wave radar as the Apache, enabling it to conduct reconnaissance while masked behind hills and tree lanes. Data from multiple sensors could be fed into an automatic target recognition and tracking system, and shared instantly with friendly forces, much like the real-time battlefield situational awareness network found in today's F-35 fighters. The new helicopter featured a tandem twin-seat layout, allowing pilots to operate the aircraft via a dedicated helmet-mounted display and multifunctional LCD screens. Combined with night vision systems and a forward-looking infrared camera, it achieved true all-weather combat capability. Its cockpit featured an isolated, sealed design with full CBRN, chemical, biological, radiological, and nuclear protection. Equipped with a triple redundant fly-by-wire system, it boasted excellent fault tolerance, ensuring the aircraft could still fly safely even if the fuselage sustained partial damage. Following an extensive R&D phase, assembly of the first prototype began in November 1993 at Sikorsky's Connecticut plant before being transferred to Boeing's Pennsylvania facility. The first prototype finally made its official public debut on May 23, 1995, at the Sikorsky manufacturing plant. Following the unveiling, the prototype was transported to Florida to commence flight testing operations. On January 4, 1996, the prototype completed its 39-minute maiden flight and was officially designated as the RH-66 Comanche attack helicopter. A few years later, the second prototype took to the skies on March 30, 1999. By June 1, 2000, the Army determined that the aircraft fully met its core reconnaissance and attack requirements, approving the Comanche to enter a $3.1 billion engineering and manufacturing development (EMD) phase. The U.S. Army originally planned to procure 1,200 Comanche attack helicopters, with deliveries slated to begin as early as 2006. However, as R&D and testing progressed, the aircraft's flaws gradually came to light. First, packing a massive array of advanced and proven systems into a single platform mired Boeing and Sikorsky in severe cost overruns. To make matters worse, the Army kept shifting its requirements, demanding additional features and weapon payloads. As a result, the entire aircraft ended up hundreds of kilograms overweight, which degraded its flight performance. Some engineers at Boeing and Sikorsky even questioned whether the helicopter could successfully take off with a full weapons load. Furthermore, the Comanche relied heavily on its software systems, but multiple rounds of testing in the early 2000s revealed that this helicopter, nearly 20 years in development, still suffered from severe technical deficiencies in software integration, antenna performance, cannon systems, and assisted target detection algorithms. These issues included frequent software bugs, sensor instability, and radar-absorbing materials that were prone to corrosion in rainy weather. As costs soared, the monumental impact of the collapse of the Soviet Union triggered massive budget cuts. This helicopter, specifically engineered to counter the Soviets, lost its adversary overnight. The war in Afghanistan and the war on terror completely shifted the military's focus away from Cold War design parameters, making the mass acquisition of a stealth attack helicopter unnecessary. Deprived of geopolitical conflict and the threat of nuclear war, the Comanche transformed in the eyes of the Army into a problematic, budget-draining liability. On February 23, 2004, after decades of development and nearly $7 billion spent, the Comanche program was officially canceled. There were two primary reasons behind the cancellation. First, the Comanche's operational role was unnecessary in the short term and logistically unfeasible in the long term. Second, like all rotary-wing aircraft, the Comanche placed an immense drain on strategic airlift resources, offering poor cost-effectiveness. Ironically, it had once been proposed that the Comanche serve as a command platform to direct reconnaissance drones in combat, an idea that ultimately accelerated its demise as the military realized there was no need to use a manned helicopter as a data intermediary. With rapid advancements in drone technology, command headquarters could directly control UAVs in battle. Yet, the Comanche program was far from a total loss. Its greatest value lay in pioneering a suite of advanced technologies that were later applied to the MH-60 Black Hawk stealth special operations helicopters, which participated in numerous classified operations, including the raid that killed Osama bin Laden. Like many projects that were simply too far ahead of their time, the Comanche's ultimate fate was to be sent to a museum. Today, both prototypes are on display at the U.S. Army Aviation Museum in Fort Rucker, Alabama, standing as one of the most poignant what-ifs in the history of American military aviation. Looking back at its journey, the Comanche was never a failure of design, but rather a visionary aircraft born into the wrong era. 3 decades ago, it pioneered the design concepts of helicopter stealth, digitization, and intelligent, silent penetration, defining the evolutionary path for future low-altitude combat long before its time. It was not defeated by performance flaws, but by a changing world and shifting paradigms of warfare. The fierce arms race of the Cold War forged its uncompromising design, while the peaceful landscape that followed the Cold War completely stripped away its mission. Ultimately, its tragic fate leaves us with a stark lesson. No matter how cutting-edge the technology or how flawless the equipment, if it falls out of step with the needs of the times, it is destined to become a tragic relic of the past.